And we are a go.
Look at that. Look at that spring break edition.
spring.
I feel like we did an
Coming to you from Cancun.
That's woohoo!
No, I was going to say I wish, but no, I don't wish.
Hey, and if you're watching the video, you don't know what's in our coffee mugs. Almond latte.
Don't say that. We're a dry campus. Yes,
that's true. That's true. It is just an almond latte, but the mind can wonder and wander at the same time. I don't know. I think today, Andrew, I was like, we need to just have some fun.
We absolutely. Well, we always have fun, but we need even more fun this week.
I think Andrew and I were talking right before we hit record. I'm like, my brain is just like liquefied with all, because there's all these different kinds of course prep going on and things moving and all this stuff. And I was like, even last night I was thinking, I'm like, okay, so as getting ready for the show, I'm like, I wanted to have some brain candy, like just fun stuff. And again, we always have fun, but it's sometimes, we dip a lot into the serious natures of stuff. And honestly, I was having so much fun revisiting a podcast that we did before where I was listening to, like, we're talking about like the frog, infusing the frog DNA in human goop. And I was just like, yes, we need more of that.
I forgot about that. One hasn't come out yet, has it?
Yeah.
Or actually, maybe it has.
Yeah,
yes, it was this week. Yes, I haven't got to that bit. I was listening in the car this morning.
It's all twisted in my mind because it's like, I'm always, it is one of those, again, it's not a, it's a place.
How much fun can you have with Futures?
It turns out a lot. That's the dirty secret when people are like, what got you into Futures? You're like, actually, don't tell anyone. It is like an absolute blast from start to finish. So, but I want to keep it all to myself, maybe. No, not really, because I'm going to go teach a whole bunch of students.
There we are.
We're spread the love.
Yes.
And it's always cool to see.
And you're teaching 3 courses next? Next half semester.
Yep.
So think of all the fun those students are going to have.
That's right. And also those times when you're like, is this going to be future Sean's problem or his delight? And you're like, man, past Sean, why have you done this to me?
Yes.
But no, I'm really excited and looking forward to it. And it is one of those things where I think my excitement about it tends to bubble over and, get people excited. But anyway, I thought today we could do, I feel like it's becoming somewhat of a tradition of ours on a break week. We get into like the Futures Improv space. So I've pulled together a little bit of a Futures Improv around power, probes, and post-human civilization.
The sort of catchy title that will kill us on YouTube.
What title doesn't kill us on YouTube? Maybe another good example.
So actually, the more important question is: do you remember which button is the right jingle?
Oh my God, I do not. I do not. So this is going.
So this could be jingles improv as well.
This could be rapid fire jingles as well. Why don't we take a quick break and we'll jump back in and we can just dive right into the, which I hope will be a fun, wandering Futures Improv.
And we're back.
And I was just realizing during the break we should have tested out the buttons. But, that's the way it is. But you're with us on a spring break edition with me, Sean, and my amazing co-host extraordinaire,
Andrew Maynard.
And that means this is Modem Futura, the show that explores the intersection of technology, society, and the possible, probable, and preferable futures, asking deep questions like what will it mean to be human in the future. And like I said, I've teed up us. That's a weird one to say. A Futures Improv. We're kind of exploring this idea of, what is our human capacity or perhaps even destiny to continuously pursue the control of energy or power in that sense?
Yep. Okay, so
to the benefit of human race.
I'm glad you clarified that. So this is power in terms of energy power.
Energy power.
Not world domination power.
But I suppose that potentially they may go hand in hand, right? I guess. We'll see.
Well, this is improv, so we'll see
Let's
where
see.
it goes.
Okay, so now the question is, all right, so on our board, we have I have three greenish looking things that tell me these are where you start. And I think it's this one.
Okay.
Let's give it a roll. Let's see if we hit it.
It's time.
Yeah, that's a short one.
For Futures Improv.
Yeah.
On
I nailed
the spot.
That's the last time we did Futures Improv. I was like, I'm pretty sure it's this button. And so for people who have, if you're a return listener, you of course know the fun that Futures Improv brings. If you're new, Futures Improv is essentially a completely sort of improvised conversation. We throw out some pretty radical ideas, phrases, or scenarios, and then we just have fun riffing off those and see what we kind of go with. So, like I said, originally I had given, and so a lot of the original scenarios or prompts are AI generated. So basically what I do is I throw in this elaborate prompt saying like, pull from science fiction and pull from our other shows and pull from these sort of all the corners of the globe, if you will, to surface some wild and fun, some things. And so it gives us a list and I don't even edit it. We just go right from that and we
see where we end up.
We see where we end up. And oftentimes it's usually a lot of fun. But I think if I were to categorize this one, it would be called Power Probes and Post-Human Civilization. Because again, I was like, I want something fun. Take me away. Right. I want some escapism here. Take me away.
This so many directions. I dealt with the power. I haven't even got to the probes yet.
Yep. So this, and I think it did a good job. I was scanning it over really quick and I was like, okay, this is fun. Okay. All right. So to get us warmed up here, we're going to talk about civilizational scale and the Kardashev types.
Okay. Yes.
Yeah. And so one thing I did pull was a description because I'm guessing a lot of people may not. Some people probably have heard of the Kardashev scale.
But probably many haven't.
Most not. So what it is, the Kardashev scale is a method of measuring a civilization's level of technological advancement based on the amount of energy it's capable of harnessing and using. The measure was proposed by a Soviet astronomer, Nikolai Kardashev, in 1964, and thus was named after him. But with this idea of, so if you think about it, there's essentially three main types of a civilization. So type 1 controls the entire energy systems of a planet.
Yes.
Which we are not even at yet. Right. So to be clear, the human race is nowhere near a type 1 yet.
Yes.
Type 2 is that you can control and harness the energy of an entire solar system. Yes. So your whatever your local sun,
sort of small thinking. I'm not really thinking big. Just a solar system.
You just get your sun. Whatever your star is. And then a type 3 is an entire galaxy. So you're getting onto the level of Marvel comics.
So you've got to ask what this guy was on when he came up with this scale.
Something fun. Right. I don't know. Maybe he was on spring break in Cancun in 1964. Probably a different time. I'm just going to throw that out there. So understanding that we have this way of kind of talking about hypothetically, obviously, because again, humans, which if you look at our own, as of today, or even as you might project into 100 years in the future, nowhere near capable of harnessing with control the energy as it is in total of a planetary system.
And of course, when you're thinking about that, you're thinking about everything from the stored energy in, say, fossil fuels or sort of nuclear materials to the energy that is around us in sort of water flows, oceans, the atmosphere, electrical energy, everything, every conceivable form of energy.
That's right.
Yes.
Yeah. And if you think about it now, I don't know what the scale is currently. If you would say currently today we harness X percent of the Earth's energy, but very little. When you think about how much energy we produce, but how much is left. Again, even if you do the calculation, which kind of gets into the type 2 a little bit of just how much energy from our sun washes across the entire planet that goes completely uncaptured.
Sure. Yes.
Right. Most of it. Right. So we capture some through normal processes like.
And I'm assuming that this actually includes that radiative energy. So we're looking at stuff that comes in from the sun specifically to the planet, as well as everything which is embedded within the planet.
Absolutely. Yes. So all the geothermic energy, right? If you think even that, we have a core that is creating, amazing amounts of energy in terms of the sort of volcanic and live, the living planet part where we have tectonic plates moving. Incredible amounts of energy that are untapped. A little bit here and there, but again, thinking about, so one of the scenarios that this thing sort of generated around this sort of Kardashev scale was, if we were to reach hypothetically So let's say like in 1,000 years, so in 3026, humanity has reached a type 1 status. We've managed to again harness that energy. So wind, geothermic, radiation, everything that is the power that is capable on planet Earth, we are able to harness for our own purposes. So we can. There is no energy shortage. There is no energy crisis. We can do whatever we want with this energy. So the prompt then is humanity just hit type 1 status and now are in full control of Earth's energy systems. But the UN immediately fractures into 2 factions.
Okay.
One wants to push toward type 2 civilization. The other says enough is enough and we have enough power for the species. What happens next and who's right? State your opinion.
So there's immediately a paradox here.
Yeah.
Because the idea with type 1 is you enter an age of abundance. And to clarify that, many people, especially looking at futures, would say we're in an age of scarcity at the moment. And scarcity drives everything. It drives the economy. It drives our economic models, our political models, because we are always in a state of somebody or something having more than others. And we're always negotiating in that scarcity. When you get to type 1, in principle, when you're harnessing all of that energy, we should be in a state of abundance where anybody can pretty much do anything they want on the planet. Apart from the fact that if that was the case, it's hard to see where there would be fractions because anybody can do anything. Apart from the fact that, and this is very telling, because the question assumes that our ability as humans to imagine what doesn't exist far extends the resources that we have. So even when we have everything on Earth, this idea says that because of our nature as humans, we will want more. So we will always have this scarcity mindset where even when we've got everything, we'll think, well, we could have a little bit more. And that's where the tension comes. Those that sort of aren't satisfied with having everything and those that are.
Yeah. Well, and I feel what's interesting. So when I read this too, I'm like, when I read it, I had a similar reaction to that too, as like, this just lends into that insatiable desire for what's over. I mean, call it, maybe it's exploratory, maybe it's
what's driven our sort of our social evolution, if you like, and our innovation evolution.
I mean, probably we would have lived happy lives in a cave somewhere, and that would have been
with a couple of sticks.
Yeah, a couple of sticks, and maybe a fire. I don't know, and that would have been fine.
Yes,
it was, and then that drive to like move out, and what happens when I heat this thing? Oh, look at But so when I read that kind of had that first thing too. But then as I read it just now to you and you were responding, I'm like, what it doesn't say in here though is that everyone has access to that energy.
Yeah.
So there is this bit too where like, again.
So this really isn't an age of abundance. It's still an age of scarcity.
Someone's
it's just
abundance.
It's somebody's abundance. But you have to assume that some people won't have access to that. So to them, it's an age of scarcity still.
And so you wonder too, I mean, again, just thinking, this is what's fun about this too. If you really push that timeline out, like even 1,000 years might be, I mean, that's really giving us a little too much credit, I think. It could be.
AI is going to have solved everything by then.
Well, you know what? The AI has restate this. Artificial intelligence just hit a type 1 civilization.
There we are,
The humans have moved back to the caves.
But actually, that gets even worse because if AI reaches type 1 civilization, humans are part of the energy equation.
That's right.
Sort of extracting the energy in our bodies.
That's right.
This becomes very Matrix-like.
And there is your paperclip maximizer there.
Yes.
Right. But or it is, well, that's the fun part too. Like that, but the good thing about the Matrix, I can't remember who was saying this, but it's like humans actually don't make good batteries. Right. So like, so that really
for those of you who are scratching your head listening to this, the whole idea of the film The Matrix is this sort of super intelligence sort of machine that the AIs have decided that humans make brilliant batteries. So they basically sort of they create us and put us in pods and harvest the energy from us. Yes, while making us believe that we're all living these wonderful lives.
Yeah, which you're like, that seems like, I mean, maybe that's a very gracious thing for them to do, because also I'm like, we would be a very inefficient battery,
Right.
like.
But why put all that energy back into sort of making us feel as if we're living in? Actually, no, I do remember there was a plot line here because they discovered that we make very poor batteries if we're not happy, or if we're not striving against.
That's
something.
That's right. So anytime you have a bad day, you're like, apparently I needed to output a little bit more energy.
That's right.
In the system.
The Matrix, yes.
Back into the Matrix. But thinking about this too, I think think is really sort of fun because when you think, like for me, again, I like this idea of, so if we think about, okay, so 2,000 years, 3,000 years, 5,000 years from now, right? What might be able to change? And if you think, again, science fiction, we have lots of examples that go all kinds of directions. I think in the more sort of utopian sort of style, you have more of the Star Trek sort of aim where like planet Earth becomes a post-scarcity model.
Yes,
it's still not a type 1 civilization in that sort of imagined science fiction future. Or maybe it is. I don't know if they ever really, I don't even know if they even touch on that, but
no, but definitely this idea of post-scarcity. And I think one of the ways of understanding that is if anybody's familiar with Maslow's hierarchy of what is
needs.
Needs.
Yep.
Yes. You now have a civilization where everybody has the ability for not only their basic needs to be met, but needs higher up that hierarchy to be met. So there is a lack of scarcity of need.
Yeah, and thinking about that too, right? So if you think about this like almost like pyramid shape, right, where at the bottom of that is the most core essentials. You need food, water, shelter to survive. And then once those needs are taken care of, then it's like these other higher order ones that become more like, you have to have fulfillment and joy and these. But if you can't eat or have a place to sleep or have water, the joy, that's just not that's not on the table. But if you can take away those or remove the scarcity for those bottom as many layers as you can, what you left at the top is all the things like which we dance around and we flirt with these terms a lot too when we think about even more near-term stuff like universal basic income and these things that would take away societal pressures. Leaving with the question like, well, what would humans do if we didn't have to do the hard slog part to like to ensure basic survival, right?
And of course, this is the idea of all of these sort of concepts, whether it's sort of post-scarcity or whether it's sort of an age of abundance and things. But here is the challenge. So all thinking around this, all sort of technology and utopia-based thinking assumes that if only we get the technology right or the energy harvesting right, everything will be great. And what they forget about is human nature. As soon as you throw humans into this, and we know this because you look at the world at the moment, the world, even with the energy harvesting we have at the moment, could be an amazing place for everybody.
Could be shared.
It's just that we have this inbuilt desire to grab resources to ourselves. And you can trace that back to our evolutionary heritage. But even if everybody has access to everything, people are going to instinctively want more and take it away from other people. So you always have this disparity. And to me, the fact that we have that in the world at the moment suggests that even if we increase the amount of energy availability 1,000-fold, you're still going to have that disparity.
And I think that's what's kind of interesting because I think that comes back to also the dual meaning of the word I used when I said power. Right? Is that yes, I think it is sort of in that nature where that we've demonstrated so far. And there leaves a big question because I think, if we again look dramatically outwards into the cosmos, right? So into our solar system, our galaxy and beyond, always asking, there's always those questions at play too around like, well, could humans or if we discover other alien civilizations, will they have the same sort of like desire to like invade and take over all of our resources? And, in part of that, we've talked at episodes before about how that is also a projection of our own self onto others. But even just when you think about that, you're like, well, how would we, like if we got to that level, how would we behave as a species in sort of that like galactic or, interstellar sort of like, what kind of interstellar neighbor would we be? Would we really be like, hey, you know what? Alpha Centauri is looking pretty good. Let's go harvest that stuff, man.
Right. And it is such an interesting and complex question. And there's been massive amounts of research and thinking over the decades and centuries around this. And a lot of it boils down to, is selfishness endemic to being human? Is it hard-coded into our DNA, or is it something that's learned and something that can be adapted? And what makes this even more complex is you look at ideas such as cooperation. And humans are really sort of complicated and weird because on one hand, we're really good at cooperating. We're really good at sharing.
Yep.
We're really good when we get people together of people
when-
helping each other out.
Yep.
And yet at the same time, the same people, you put them in a slightly different situation and it's all about a power grab.
Yeah. Or they'll tear each other down for,
Right,
you
yes,
know.
yeah.
Yeah. It's one of those, it's in many ways when you think about it at this, again, for the fun of it, I like to go and think about it on these galactic scales where I'm like, I got to get out of here. I got to leave into a mind space where there is nothing. Right.
Yeah.
But you wonder about that in some ways. That is sort of like the ultimate tragedy of humans is that ability for both of those spectrums to exist simultaneously within a person, within a culture, within a society. Like, and then how do you know which one you're going to get?
Right. And so you now look at it from the perspective of another civilization. And I think the jury is completely out in terms of asking whether to reach a certain level of civilization, you've got to have this sort of little devil inside that pushes you to selfishness as well as sort of cooperation, or whether that's something that is unique to humans.
Yeah.
And you can model this out, but I'm not sure anybody really has a good answer to that.
Yeah, no. And I think it's interesting too, again, thinking about those scales, right? So like how much time, like again, humans, we've been around on this planet for a while and we have advanced to some pretty nifty technology. But again, we are nowhere near this type 1.
Right.
Which maybe never is even possible, right?
Yes,
I mean, that's a piece to this as well, that might not be ever possible.
Yeah.
But that leads into one of the other pieces here.
Yes.
That was, and I love the way this is kind of like, I didn't do this. It kind of built up.
Right. Okay.
Because so like assuming one could get to that point where we've reached a stage 1 or a type 1 Kardashev civilization and looking for that hunger of like, well, we need more, right? Is moving on to something in the sort of the solar system control. So meaning that you can harness the power of your local star.
Yes.
And then we get into things that are really fun places to think about, which is like Dyson spheres.
That's right. Yes. So the Dyson sphere idea being that you build a sphere around the whole sun, which means that every single bit of energy that is radiated out from the sun, you harvest.
Yes.
And so there are complications with this that we might get to, but that's the idea. It gives you an amazing abundance of energy in principle.
So if you think, so even going back to the original thing, right? So imagine Earth as it is, and we get all the sun we get from, maximum are 12 hours of daylight, and you're out there with your little solar panel being like, oh, let me capture some, right? And you get enough to charge up a little battery, but that's not enough. How are you going to conquer a solar system with that measly little thing? So like, I know, hey, that sun is burning 24 hours a day, 365 a day. Why don't we put solar panels around the whole sun?
Yes.
And that's what these Dyson spheres are, which again, these are hypothetical, and I love this term, megastructures.
Yes.
Right? You can't say, when you're talking about things that would go around a star, it's not like a big thing. You have to use words like, I don't even think mega is big enough.
It's unbelievably
so,
big.
Because I mean, you think about like the construction of this, if it were to be possible, the evidence of it, first of all, would indicate such a high technological advancement that some kind of species could build a technological structure that is essentially the diameter of an orbit.
Yes.
Because it has to be far enough away.
Not even a planet, massively bigger than a planet, a whole orbit.
Right.
Yes.
And so when you think about, oftentimes you have those illustrations of like the solar system and you see like the little ring representing the path around the sun. Yeah. But now imagine that as a spherical, volume that is completely covered. Not something where it's like, between here and Mars is another panel, and then blocked out, right? Yeah. And I guess you could have partial spheres or things like this that don't, because that's one of the things is if you build a Dyson sphere, then you also dim the light from or remove it.
Remove it, and that's the thing that really troubles me. If you have a perfect Dyson sphere, everything outside that, you see nothing.
Yeah, I mean, you get a dark star.
You get a dark star. I know,
which is super cool. I mean, cool and terrifying also in the same.
So in other words, so where would you build it? Would you build it between the Earth and the Sun? If you did, the Earth immediately loses all of its power, all of its light from the Sun. So everything that has to be artificial. Yeah. So then, alternatively, you build it between the Earth and Mars, which means we're great, but the poor folks on Mars with Elon Musk's mission to populate Mars. Sorry. Yep.
Or
the light light has gone out.
Exactly. Or you build it in such a way where it always stays on the far side of the sun, right? So
Sorry,
that
a partial one.
So
Yeah.
it moves. It moves in orbit, so it stays on the far side of the sun.
Now that gets more intriguing. So
Yeah.
it's not a Dyson sphere. It's just a massive solar cell that is always opposite to the Earth,
it's like,
rotating in sort of counterpoint.
right.
To
It's like
us.
it's a half sphere. It's a hemisphere around.
Although it's also difficult for those planets where when they're behind the half sphere, the hemisphere.
That's not Earth's problem, baby.
Right. but also the gravitational pull of this sphere is going to mess the solar system up.
Absolutely, absolutely, and also just so what I would always say is like, okay, so if you do that, also, how do you harness that energy? Right, like, do you have a cable that runs? Someone forgot to plug in the Dyson sphere.
Sorry, services are out again.
Yeah, exactly. So, I mean, I would imagine then you have an entire industrial complex of some sort on the back of this sphere, on the surface of the Dyson sphere. Because otherwise, how would you get the energy from there to use it?
But then that raises the question. So if you do build this hemisphere, so you've got this massive, massive structure, and then this little Earth thing over here. Why bother still living on the Earth? Why not build other structures to live on? And of course, this is where other science fiction thinkers come with this idea of orbitals and a whole bunch of things where you actually recreate planet-like conditions with fully artificial structures. That would make way more sense.
It would. And that's where you get into these really cool things like ring worlds and stuff like that, which are basically, I mean, just the concept of that is really cool.
Yes.
But yeah, and I learned something new. So a similar thing that is sort of coupled with Dyson Spheres. I had never heard of this before, so I'm curious if you have. And I'm probably going to butcher it because it's a Russian name, which is named after those nesting dolls. Hold on, I gotta
Matrioshka.
Yes, I'm ahead to like practice this in my head for a second. I'm like, a Matrioshka brain.
Yes.
Have you ever heard of a Matrioshka brain?
I have not.
Okay,
I don't think I have. Yes.
This was completely new to me.
Yes.
But it makes a lot of sense. So if you have, again, the technological capability of doing something Dyson sphere-like, right?
Yep.
That this Matrioshka brain, again, named after the Russian nesting dolls, is a hypothetical megastructure, obviously, of immense computational capacity. So basically putting if you would imagine whatever the most sophisticated AI computational systems that are harvesting pure energy off of a sun to power themselves. That you basically, and a lot of that then kind of draws, for me, I went right to Hitchhikers, of course, of like, that's what Earth was for.
Right, that's right. A massive computer. Yes.
Make a big computer. But that you could have a computer on the scale, and not even planetary scale, on a star level scale of a computing device. And then what could be possible with that? And you're like,
so that gets kind of interesting.
It gets really interesting.
Actually, just play that out. So if you look at the current interest in AI and data centers in particular, so many challenges with this. So really powerful AI systems require these massive banks of processors and all the gizmos that go with that, which require massive amounts of energy. So you now have multiple challenges. You have the generating the energy that's going to power them. You've got the distribution of that energy, which is not trivial, both distributing it from the power source to these data centers and then through the data centers. And then you've got the removal of heat from them. So the best way to do this is to integrate everything together. And how better to integrate it than have these massive, effectively, solar panels in space that have got the processors, the data centers integrated into them. So that direct coupling there. And of course, in space, you've got various ways of getting rid of the heat. So that sometimes gets a little complex. So then the idea of creating these sort of massive Dyson sphere-like structures that are all compute substrate, because you have the energy there, you have the distributed energy sort of sources there, you have the distributed connections there. That gets exciting and weird and just a little worrying.
I mean, I think Anthropic's Claude is pretty cool. And that's just in a few warehouses on planet Earth.
So this is where you open sort of Claude Opus 4.6 and say, hypothetically, just create the blueprints for a Dyson sphere, which is actually a compute substrate, which is going to be one mega computer of an AI computer.
And then what do you do when it says, we've already done that? we're coming to you. Where do you think the idea of us
Right.
came from? Because, and so I raise this too, because again, while the proof of existence of a Dyson sphere is purely hypothetical, that doesn't mean there has not been a lot of speculation that one has been observed.
Right.
Which is really cool. So I dug into this just a little bit because again, I'm fascinated by every time someone's like, we've found aliens, you're like, well, no. Trust me, no one wants to see a space whale more than I do. But I also know it's like when first things come in, like the Hawaiian name of the interstellar object, Omu or something.
I wouldn't even try pronouncing it, but yes, the big long black thing.
Yes. The space object
that came into our solar system, and there was all this speculation about what it was.
And now there's the other one, the ITM something interstellar.
Why do they give them these names which are just hard to grapple with when you're doing it on the fly on a podcast?
They just need to call them like UFO 1 and UFO 2.
Right.
So when people see those things, you're like, okay, like let's most likely not, but it would be amazing if it was.
Yeah.
But the Dyson sphere is an interesting thing because we have gotten very sophisticated and it's increasing. And that's just in terms of being able to do planet spotting, which, I remember as a kid when I grew up, I was convinced that of course there are other planets outside of our solar system, but none had been confirmed and so it was always like, well, we don't know. And I'm like, it's impossible that we're the only lumps of rocks in this.
Right. And conventional wisdom, before sort of, I guess we're going back, 5-10 years now, it is that recent.
Yeah.
Conventional wisdom was that Earth is so unique. That the chances of finding sort of not only other planets in other solar systems, but habitable planets is sort of minimal.
A Goldilocks termed planet where
and then we had sort of the next sort of generation of space telescopes coming along, including the James Webb telescope, and all of a sudden these things started popping up left, right, and center.
Crazy.
But the way we discover them is amazing. So you can look at a star that is light years away, and I forget how many hundreds of light years you can go.
Pretty far.
Unbelievable distances away. Yeah. And what we can do is we can measure with these telescopes the occlusion of light from that with a planet crossing in front of it. Imagine you look at a pinprick of a star hundreds of light years away, and we can detect this ball of rock moving in front of that and say that is not only a planet, but it is a planet with certain characteristics.
Yep. And that's one of the amazing things when people ask about like, what are some actual demonstrable benefits of artificial intelligence in science? I'm like, just combing through the light data.
Right.
Because that's exactly it. I mean, if you want to do this at home, right? To show how hard this is, right? Is like have someone in your family stand like across the room with a flashlight and then move like something the size of a fly across it and tell see if you can notice.
Say the tip of a pin across it.
Tip of a pin. A grain of sand. A little
or even smaller than that. I mean, it's like sort of if you had a flashlight, it's sort of a little cluster of atoms going across it.
Dust particle goes across it. So then, we have this ability then to measure and define, because again, one of these ultimate sadnesses of how big and how just unobtainable the distance of space is like, I would like, how cool would it be to be able to look through some kind of telescope and see optically another planet, right? Like outside of our solar system. And it's just never going to happen, not with this kind of stuff. But what we can measure is exactly like, you can measure how planets, and only the ones that traverse on the axis of that star. So if they're on a 90-degree axis, you'll never see them because it's just pure darkness.
That's right. Yes.
But so we've now, I don't even know what the count is now, but it's like, I think it's like in the hundreds of.
Oh no. So a few years ago when I was writing about this, it was in the thousands. So it must be way above that now.
And maybe it was hundreds for like Earth Goldilocks type, like hard, planets that are of solid material and close enough to their star where, I mean, I remember even finding these cool things like calling like the hot Jupiters that are Jupiter-sized planet, really close, like Mercury level close to their sun. Just like hot Jupiter, it's like it's boiling.
That's a pretty good phrase. Hot
Jupiter, man. It's like who doesn't want to be a hot Jupiter? I'm just saying, But then, so coming to this Dyson sphere thing, there's been, and again, scientists who have made the observations have not called them Dyson spheres. But what they have noticed is different types of occlusions on a sun that are mysterious.
Right.
Because they're not behaving.
They don't feel natural.
They don't feel natural, and they're not behaving the way a planet traversing the star does. Yeah. And so if you go to like the wikis, if you just type in Dyson sphere and you look up, you can find a lot of the origins of.
You go down that
it's a great rabbit hole.
Conspiracy theory rabbit hole. Yes.
But I pulled this one because it was, I think, one of the more recent ones in 2024. There was a lot of press speculation. Again, the authors of the paper did not insinuate that they found a Dyson sphere, but there was nonetheless a lot of speculation around it. And there basically have been 7 objects of interest that are all located within about 1,000 light years from Earth. So in terms of that classification, kind of close. I mean, even though, again, you can't get there unless you travel at the speed of light for 1,000 years.
Yes.
But they're around like these M dwarf class sort of planet stars that are smaller and less luminous than our star. But basically, when they were describing the patterns, it was as if there was something massive that was blocking way more of the light than would be accountable if it was a planet.
Right.
Now, that being said, most likely it's something between us and that.
Yes.
That's somewhere in the mystery, like dust or huge thing we can't see. But it nonetheless, it also for those authors, and there is a time period where they'll be able to check it again to see if to measure, say, how has it changed since the last time we were able to measure it. But nonetheless, it also has not been ruled out because they're like, we see this thing. We don't know what it is. It could be something like that, but it also could be something half the distance away that is blocking our view.
Yes.
We don't know.
But to me, it attests to just the amazingness of this, but also the frustration. So we will never know for sure, unless, as you said, somebody breaks the speed of light in terms of travel, which at the moment is just beyond hypothetical. But we can get these tantalizing glimpses into the universe and the galaxy. Yeah. We can never be absolutely sure what we can see, and we can never visit to verify.
I know.
They're always beyond grasp.
That was one of the, for me, I can tell you right now, as a child, I was fascinated with my telescope and all this kind of stuff, and would just spend so much time mentally just trying to explore those worlds outward. But then ultimately there is a real sadness for me around that, of knowing like we will never, as a human, certainly in my life, I still remember being like, so if I grew up, like, would I ever be able to visit another planet? I'm like, no, not really. Not with, but with probes, hopefully, right? We can do that. But so ultimately there was this sadness of like, we'll never know. And even just observationally, the distance and scales, the light that we observe is so old, and which is fascinating. You point
which is the other thing. 1,000 light years.
1,000 light years. Which means that like the equivalent, that star could be they could be let's call it anti-Sean is on that planet looking at me with a telescope as I'm looking at them. The light they're seeing is from 1926 or whatever. 926.
Yes.
And not 100 years, 1,000 years.
Going back to the pre-dark ages.
Or if it's farther and farther and farther, so there is a full potential, right? That also this sort of emptiness of, there's lots of things around like the Fermi paradox and things about that, where people are like, well, where is everybody? Right. But if you think about the scale, entire, like, we'll call them intelligent just to, that they're capable of what we are capable or more, of these massive systems that could rise and fall. But because of the distance, you're never going to align in a way to actually make a meaningful connection. Right. So, because if you think about us, right, we've had the capability to detect, let's say an alien civilization was like, hey guys, we're here.
Right. Yes.
If you answer us, we will come there.
So with radio, and especially with sort of powerful radio telescopes, we've had that for
80 years, 90 years?
Maybe a little less than that, but sort of suddenly 50 or 60. Yes.
Yeah. And so, and if you think about it, like we could, this is kind of a fun thing too. You go back to like, perhaps like, the Middle Ages or something, and we're sitting around there playing in the dirt and the muck. Meanwhile, there's a alien space.
So, hey,
if you guys could only answer us if do you want to join us? And we're just out here like, just completely oblivious to it.
But you flip that round as well. So imagine that as the Modem Futura podcast gets broadcast out into the galaxy, and some alien civilization picks it up 1,000 years from now and thinks, that's really cool. I'd like to go and hang out with those guys. And then it's going to take them 2,000 or 3,000 years to get here because they can't quite travel the speed of light.
Yeah.
So say about sort of 5,000 years from this point, they turn up on Earth sort of saying, hey, I'd like to hang out with you. What will they find?
Yeah, well, hopefully a active and thriving post-scarcity civilization.
Right.
Then I'm also
a couple of brains in jars, sort of broadcasting out Modem Futura every week.
Then it gets you thinking like, well, maybe it's like a time capsule. You could put a DNA sample, fire that bad boy up into a stable orbit, so you could collect it, grow us back, and there we go. We're off and running. But no, I think that the Dyson Sphere stuff is really fun to think about, and also it reminds me. The other piece that it kind of brings in is, again, kind of tying into some science fiction elements. A couple of things. One, are you familiar? Have you read the series or seen the Amazon series of The Expanse? Do you know this?
I've read the first book. To be honest,
wasn't for you.
Didn't really get on with it, but yes, I know it.
Yeah, so it's an interesting. I mean, it's a good television series on its own right. The book series is of course my preferred way. It's a series written by James S.A. Corey, and it basically takes this the premise of it is essentially is like a near future where we have colonized.
We're expanding out into the solar system.
Yeah, so we have colonies on Mars, and more fascinating, like basically the belt, so the asteroid belt, and it's neat there too. Because they talk about, if people who are humans who are born and live in these, sort of like in the Rust Belt, for example, they're super tall and very lean because of the low gravity and all that. It's just kind of a fun thing.
They've adapted, yes.
And it's it's a fun exploration. But the premise of that too is that as the humans are expanding, they basically discover these they call them rings, that they are these artifacts left by some sort of type 2-ish civilization that has mastered technology in a way that allows humans to basically jump. They're basically like wormholes that you basically jump through space. Yes. But what the eerie background of this is that we discover, if you will, basically this interstellar highway that has been built by some civilization that doesn't appear to be around anymore.
Right. This is the residue, effectively, yes.
Yeah, and then it's sort of like as the series unfolds, you learn more and more where they're like, part of this mystery becomes, well, who destroyed the ring builders? And that starts to unravel, like, it's like there's always a bigger fish.
Right,
and so you start to unravel this, like, there's an element of like mystery and terror and all that kind of stuff as you grow on this bigger scale. But also this, again, thing is like, if we are able to detect something, or I don't, again, how or to what extent we could ever confirm we find a Dyson Sphere would be interesting. But even just hypothetically, if we find remnants of other markers, right, that you're like, well, that's a fun space for me to think about. Because I'm like, what would happen? Even just in present day, if suddenly we stumbled upon, when we crack the ice in one of the frozen moons.
You find these you've been watching way too many sci-fi movies.
I tell you, I needed a scare. I told you, I warned you. I said we're escaping today.
But what I find makes this so intriguing is you think about the age of the known universe, and what is it? I'm a physicist, and I always get mixed up with powers of 10 sort of billions, whatever. What were you, 13?
I think billion years? The most updated one was like 13.8 billion years or something to that extent.
So the universe has been around for a while, and actually the Earth has been around for much less time, and humans for just a fraction of that. So in real terms, there was a lot of time before anything in the solar system developed. And that's a lot of time for something, a civilization, something to emerge, to build stuff, and then disappear. So actually, conceptually, it's not as crazy as it might sound.
No, and it's funny because when you listen to people talk, I mean, when you look at, like, again, the size, the scale, and even just the math, if you run about, like, even like the law of numbers, even though we might be in our solar system, if we end up being the only case, okay, we are one of, again, thousands and thousands of systems. I mean, like the numbers would say that that's happening all over the place.
Right.
But to the extent
and that's the Fermi paradox. We can't find anybody else, even though in principle they should be there.
They should be there. And so, have they self-destructed? But even, again, think about our existence here. We will have as long until our sun becomes a red giant, and basically it will eventually swallow planet Earth.
Yeah.
So we have until then to get out or find a way.
Right.
But otherwise, it will be gone.
Yes.
And so how many times has that happened in other pockets of our galaxy, other pockets in the other galaxies upon the universe? Like, it could be at any point in time teeming with life.
Yeah. But
because of that scale, you are destined to never ever be able to meet and greet and shake hands or whatever.
Apart from those civilizations that somehow get over that hump, and then of course there's the theory that there are those civilizations out there who look at humans and think, we don't want to engage with them, so they just hide themselves.
Well, that's like the drive-by.
Wait till they've grown up, maybe a couple of billion years from now.
Yeah, well, that's like the drive-by, right? We're finally visited by like a super intelligent race of extraterrestrials, and they take one look and they go,
nope,
not cool, bro. Let's just keep on going. Let's check the next one over. Keep going. We're not stopping here.
Yes. Well, actually, what you'll probably find is there are these great big intergalactic warning signs around Earth saying sort of beware. It's like the entry for hitchhikers will be updated. Instead of mostly harmless, it'll be like, stay away, turn left, turn around. But so the other piece, the other science fiction bit I'll bring in there just to kind of tie that piece up is also Contact. So, Carl Sagan's Contact, again, so not about finding a Dyson Sphere or things like that, but it was about, the focus of the novel really is about the contact, like what happens when, if that were to happen, but also just buried within there, the mechanism for that was essentially, here's a blueprint for the message that gets sent is not like a hello, it's a basically blueprint for that first contact. Yes.
If you can build this, that means you are of a civilization advancement level enough to actually come join us.
Yeah. Or at least take the first step in a long journey.
That's right.
Joining us. Yes.
And what I really liked about that premise, thinking about this, is like, if we were or ever do find evidence of these technologies, like in the Contact way, they basically left the door open. And it was sort of like, if you can, come through this door and then they'll be contacted. We can talk or whatever.
You're sort of distracting me now, because it is such a brilliant novel and a brilliant movie.
Oh, it's so good.
Deeply underappreciated.
Yes.
So last time I looked on Rotten Tomatoes, it was only 60-odd%. So I think most people sort of watch it and don't get it. And I've written about this in my book.
Sure.
I teach from it, and every time I watch it and think about it, this is the movie, and of course the book is better. I am astounded by the thinking there. So it's one of those things I would recommend everybody watch, but watch with intention. If you want the broader perspective, and read the chapter in Films from the Future. But it is so smart in how it begins to explore these things, even the timescale. So that idea, and again, I'm going back to the movie, which is slightly blander than the book.
Yeah.
The idea that the main character, Ellie, has this experience, that they build this device
sphere
that allows her to travel and experience something, so she knows what is possible, but she can't explain that to others. So it was more like a religious experience, but she knows that.
Yeah.
And then you go back to the book, these alien civilizations sort of leave this little sort of trail of breadcrumbs, but it's a trail of breadcrumbs that humanity are going to take hundreds, thousands, maybe even millions of years to follow. If they have the ability as a civilization to follow this, they may get to the point where they can walk en masse through that door and partake in this broader civilization. Yeah. But you're talking about eons here, not just a few years.
Yeah, we should do a whole episode on deep dive into that content, because it's like, maybe that's I'll throw that out there of maybe one to start with, of like a Modem Futura book club. Because that book, also in there, one of the things that is so fascinating, and in my mind, as I'm talking right now, I'm conflating both the book and the film together, with Jodie Foster and Matthew McConaughey is in it. I think he plays the love interest at the beginning.
He does, and at the end, yes.
But one of the things is, again, it's that tragedy of this thing of, in the movie, they do a great job of this visualization of they have this alien spec and we were able to unpack it and build this device. And then the humans are like, yeah, but we need to put a chair in there because where does the person sit? And so they put this thing, and then of course that everything is like horrible and terrible. And it's and it's the human thing, and they kick that off, and everything's fine.
Yes,
and it was, but again, that like,
lack of trust,
that lack of trust.
We're humans, we know best. Yes.
Or that, or even it's that there's something to that. But but then again, in I know I'm not going to spoil anything, but. Again, when you watch it or you read it, you pay close attention to how her experience is different than the people who are observing her have the experience.
Yes.
Because it is just so cool how it takes you and you can see these different possibilities. And again, like you said, it's like these different transom of doors being left.
Yeah.
And it's like, if you want to come, you got to put in the work.
Yeah, you got to prove that you're able to do this. But also,
so
and
cool.
it suddenly struck me as you were saying that. So you've got this sort of huge disappointment that you have this experience and there's no sort of clear, easy way forward, and you realize that the weight of loneliness here.
Yeah.
Apart from the fact that in the movie there is this sense of wonder and awe and amazement, and that's what always sort of leaves me as I watch this. And in fact, one of the ways that I describe this is Carl Sagan's love letter to science, to curiosity, to imagination. Because at the end, Jodie Foster's character, she isn't sort of depressed by the fact that she's lost this opportunity. She is amazed that this exists, and her whole motivation is doing everything possible within science to uncover what she doesn't know. And you can just see that sense of awe and a wonder and amazement in everything she does at the end.
Absolutely brilliant. And like I could go plug too. If you like to listen, the audiobook version is fantastic.
Right.
It's narrated very well. I would. That's a 5-star rating from Modem Futura. So okay, one last little bit here because we're gonna, always as usual, I'm looking at the time.
We've got distracted slightly.
Okay, so this arc is always funny for me because it's like the how. Go out in time and space and scale, and then that loneliness of like, but we'll never actually be able to go there. And then the one thing that kind of brings me back is a little bit of joy because it's like, actually, there may be a way.
Okay.
But not in the conventional sense. And this is where we get to our probes.
We're not going to get to sort of human gloop again, are we?
Well, yeah, you can see a little bit. And so the other piece is, again, this is where we roll in like, okay, because human exploration, and we've talked a little bit about just to take the shortcut here, right? Even going to one of our nearest, inter-solar system visits to Mars.
Yes.
Right. 9-month journey, roughly. Most likely, if you could go and touch and come back. Otherwise, if you stay there, you're not coming back because of the changes that will happen to your body. We know humans are not built for space. We are soft, squishy water bags that absorb radiation, and we are not built for things like low or no gravity environments, all this kind of stuff. So we are not good interstellar species. We're just not. However, we can build probes to the best of our ability to do that. And that's where the von Neumann probes come in.
Of course.
Which is, again, so this is where I get, so I'm like, okay, so you have this tragedy.
I think I know where you might be going here.
Okay, so we have this tragedy. We can't go. I think the closest thing we could do is putting ourselves into a caterpillar-like goop pod and reconstitute. But even that is dangerous because what happens to the goop, right? The goop can get irradiated and all that kind of stuff.
So biology and space don't mix well together. But hardened electronics in space
have a much better chance of survival, especially if one can self-replicate.
Right.
Now, so we have probes, right? And most famous, I should have looked up to see where it is. Our Voyager probes
is beyond the heliosphere at the moment. So beyond sort of that outer sort of layer where the sun has its influence.
So those are actually interstellar in the sense they're outside of our entire solar system, out in the nothingness, which isn't nothing, on our way. And so we have, and that happened like a year or 2 years ago when it crossed the heliosphere. There's actually a really cool audio signal that you can listen to of the transmission of when it crossed through the heliosphere. You can actually, they adjust the frequency into an audible range, but you can actually hear it, which is cool. But yeah, so this idea of a von Neumann probe is basically that the humans are able in a technological future to build a self-replicating spacecraft, right? So, because even spacecraft like the Voyager 1 have far outlived its original mission.
But it's gonna stop working at some point.
It's degrading. Because again, even things like metals and circuitry are still subjected to the tortures of radiation that will degrade them to the point where they'll stop functioning. So if it was going to truly sort of explore the universe, or at least the galaxy, it would have to have a way of repairing itself, or in some ways basically just like regenerating itself, replicating. But the idea behind it then is if you could build such a probe, you could send those out on exploratory missions to basically look for where everybody else is.
So the idea is you have this probe that lands on a planet. It's able to mine and harvest resources on that planet to replicate itself and then send the replicas off to other places. And it's basically rinse and repeat from there.
Absolutely. And if you think about, even just within our solar system, right, the prevalence of very like mineral rich asteroids and things like, which we know because we've done these amazing missions where we've actually gone and taken a little sample. So like the resources are aplenty that are out in different sorts of formations of rock, or moons or asteroids, or even entire planets. I think it would probably be easier to grab like non-atmospheric items like asteroids and comets and things like that, other than landing on the atmosphere, because then you have to escape the gravity. Anyway. But what is really cool about that is, again, if you have this potential future where you could create artificial intelligence if something like a singularity or a true brain computer implant would be possible, of putting that as a synthetic human in this capability, you would then sort of vicariously be able to explore these cosmos. And I would position, unless there is some sort of technological advancements that would prove a wormhole is possible to not only create but sustain, to pass a spaceship through, that if we were to encounter evidence of a different civilization, it would be most likely in the form of some kind of von Neumann machine.
Right. In these probes.
Because otherwise, how could anything, as far as we know, no biological creature could survive that harshness of interstellar space.
But you can imagine something that wasn't bio-based doing it. And of course, the example of this is you imagine sort of Voyager 2. And imagine at the time when that went out, we had this ability to encapsulate a self-contained advanced AI in that. So even now, even outside the solar system, you would still have that artificial intelligence functioning, assuming that you had shielded it well enough. So now you would have that little sort of glob of sort of human created intelligence going out into the galaxy, sort of beyond the solar system. And that is not beyond the realm of possibility. In fact, actually, if we made one of these probes today, we could have something similar to that, which meant that in sort of 25, 50 years from now, that little piece of sort of human-inspired intelligence would still be out there.
And think about like the cool parts of like all like the brain, like the organoids and all these things. It's so fun to think about.
So I'm actually this has got me off. So now I'm imagining sort of Voyager 2026
there you go.
going out, but it's got embedded a little sort of self-contained capsule of Anthropic's Claude or ChatGPT or Grok, for instance.
Oh my God,
So imagine you have this instance of Grok on it, and sort of on the outside in multiple sort of languages and in mathematical sort of characters, it's basically sort of saying, this is your starting prompt.
Oh my God.
So could you the alien types this in.
Can you imagine, right? So like 10 million years from now, right? The intergalactic wars that are happening between what we find as three factions that we've traced the lineage back, these idiot human beings set off these probes. One was Anthropic's Claude, another ChatGPT, another Grok. And then 10 million years in the future, there's this intergalactic space battle.
This is a seed for a really good story.
And then all traced all the way back to be like, I don't know, let's throw these into space and see what happens. Like just completely oblivious to the butterfly effect that would have, eons down the line.
Oh yeah, I love that, but it also sort of makes you wonder very, very practically. So you have large language models at the moment that have trained on sort of human language. Could you create a model so that if an alien civilization found this and started interrogating it, it could actually learn how to communicate with them? So you have that active learning capability. So it then becomes translator.
you would think that there would, I mean, assuming that another species would be able to understand, and they would have to a certain extent to understand, at least in our sort of universe, right? If they would have to have the same understanding of math and physics,
right? But that comes back actually to Contact and Sagan, because the whole point of this was the language of math. So the idea being that this is a universal. That everywhere in the universe 1 + 1 = 2, no matter what base you're dealing with. So if that was the basis of your large language model, sort of a math base.
Which is, it's a binary. I mean, it is. I mean, in that way, because that's the piece, like the symbology would most certainly be different. But it would be easier to crack because I mean, you already have sort of like, you know, what's the sheet, the cipher or whatever of, you know, what the answer would be. And then you can kind of work backwards what their symbology would be to get 1 + 1. You know,
and of course, this is the genius of Contact as well.
Square equals triangle. I don't know.
Because this is how the translation worked. It started off with very, very simple things. Like this is an equation. This symbol plus this symbol equals this symbol. So, and then you sort of build up from there. So you could actually use that same or similar approach to put in these probes with an LLM or something equivalent there that then acts as the translator or transformer.
Well, and I think it's fun too. I mean, another sci-fi book that's also a movie, it's coming out really quick, is Project Hail Mary,
of course,
which is it's a fun read. It's a fun story. But also I won't say anything. I love the ending of it.
As you're saying this, I'm trying to think whether the movie will actually be out by the time this actually broadcasts.
It'll probably hit the same week.
Right.
It'll probably hit the same week, I think. Or we might be 1 week later. I can't remember. Anyway, it's sometime in March is when the movie comes out. But in there, similar kind of thing of, you have that interspecies sort of, how do we find a way to communicate with each other? And they're able to do that again through science and math of making that connection. But going back to the previous part about the AI piece is, you know, again, going back to, you know, the 1970s when we launched Voyager, they had the golden record, which contained audio samples of all sorts of different music and is it love? What's the spoken word? Is it love or peace or something? I can't remember now.
Can't remember.
But there's samples of as many languages as we could get.
It also had a schematic on how to create a record player so you can play it.
Exactly. And also, you know, a diagram of the human body and also where we were in the solar system, right? But so think about something like that. But now if you're able to embed this way that could be potentially decoded with some mathematical translation into a binary system of a, you know, not today, but let's move down 100 years or something, in a sort of real world AI, right? So it understands the environment, so it's embodied, but also again with our ability to create simulated worlds and digital twins, you could send a digital twin of everything we have up to that point. So not only would they be able to like, hey, look, you know, this my alien voice sounds just like me. Hey, look, they sent us a probe, and it's like, what's in there? You're like, well, this annoying thing that talks to you or whatever, but also this virtual world. Right. And so then you have this virtualized world. So a sufficiently advanced civilization might
be able to reconstruct it.
Could literally see what it all looks like. And then decide what to do with it.
Put a great big warning sign saying, do not approach.
Oh my God. Can you believe when they do this? They walk around with shoes on their feet. How dare they? You know? I don't know. It's just
the entertainment of the millennia. You have people sort of gathering around saying, do you believe?
Look at this. But I think about the reverse. Like, could you imagine if we stumbled upon, so we're going to, the ice moons and things like that, right? And we crack through the surface and we deep dug in, and sadly we don't find a space whale, but we find a probe from somebody else who had done the same thing. And in that probe, we find a metaverse version of their world. Like, could you imagine how cool that would be? Or maybe terrifying, depending on what's
could go either way.
What's inside there, or you're one of those classic things. You turn it on. I feel like there's some sci-fi movie where it's just like the countdown clock begins of like now they're on their way, and you're like, okay, well we have depending on how far away they are, we've got 1,000 years before they arrive or whatever.
So, and then the whole scenario is what happens to civilization then,
and then they completely forget civilization would fall, rise again, and by the time they get there, we're still back in like again the medieval times, and now they're going, I thought these guys were cool. They answered our device, but these are a bunch of idiots.
Right.
Keep on going. And then the cycle continues.
Which all goes to show the sort of improv sort of created by whatever AI you created leads to interesting places.
It does lead to interesting places. And we shall leave it now. We'll leave it there. And now the question is the buttons for the outro. Andrew, I'm going to let you pick one. One of the three.
So the question. So okay, was it a green one or was it a red one?
Red. So green to go, red to stop.
Okay, ABC. We're gonna go for this one.
Let's try it.
This is the end of Futures Improv.
I can see by the counter it's a long one. We'll just turn it off. It's fine.
We can fade out. Yes, if you can work out which fader that is. Yes.
There's the beat. There's the chorus. Thank you, Suno, for these. And which again, the true trouble on it is getting them to do short things because they always are like,
yes.
You want 30 seconds? How about 3 minutes? I'm like, no. Okay, all right.
30 seconons? Yes. Okay, 30 seconds. Another 3 minutes.
Yes. Yeah. No, I need you to reduce it to 3 minutes. You got it, boss. 3 minutes. 3 more minutes. No, but anyway, again, Andrew, thank you for this spring break edition.
No, this has been a welcome injection of levity and sort of serious thought with a bit of fun.
Well, of course. Well, always. Yeah. Well, but that was for me. I was like, I need some escapism. I need to go out into the cosmos with my mind and explore and get sad and then get happy again and all those kind of, the kind of journey. So, in some ways we went on our own interstellar journey.
Yes. Now back to Earth with teaching looming next week.
Back to reality, back to the grind, all that kind of stuff. But yeah, amazing. And again, for all of our listeners out there, just like any successful von Neumann probe, help us spread and replicate the powers of Modem Futura by leaving us a rating and review. And of course, going that one step farther to replicate your own version by sending it to somebody, leaving us a rating and review so that more
puts a whole new meaning to going viral.
Infect someone with this, would you? Like, pass it along.
This is getting weird. Let's close this up.
Just like anything else, you sit with them, they'll listen to it. 12 days later, next thing you know, they've got it too.
There we are.
Similarly, we have an incubation period as well. I'm just going to say, no, this has been absolutely fantastic. And so Andrew, thank you, again, for it's just a fun conversation.
Always a pleasure, Sean.
So yeah, we'll see everybody on the next episode of Modem Futura.
We'll see you there.
End transmission.